Hi friends, welcome to our channel Focus Prep IAS. Today we are going to see about Aditya L1, India's first solar mission. It becomes fifth country in the world to achieve this feat. The other four being Europe, USA, China and Japan. It has been launched just 10 days after India has soft landed its Chandrayaan 3 on the moon. Come on, let's dive into the important questions and answers on this mission. Number 1. Project Director of Aditya L1. A. Nigar Shaji. B. Palanivel Veeramuthuvel. C. Ritu Karidhal Srivastava. D. Sankara Subramanian. The answer is Nigar Shaji of Tenkasi district in Tamil Nadu. B. Palanivel Veeramuthuvel is the project director of Chandrayaan 3. 2. Launch vehicle used to launch Aditya L1. A. PSLV C-48, B. PSLV XL, C. GSLV Mk3, D. PSLV C-57. The answer is D. PSLV C-57. Recently, PSLV has been ISRO's reliable source of launch vehicle. Even Chandrayaan 3 was launched with PSLV series. Launch date of Aditya L1 is A. September 1, 2023, B. September 2, 2023, C. September 3, 2023, D. September 4, 2023. The answer is B. September 2, 2023. A small hint for remembering this is Aditya L1 2. September 2 is the date. Distance from the Earth A. 1.7 million kilometer, B. 1.6 million kilometer, C. 1.5 million kilometer, D. 1.4 million kilometers. The answer is C. 1.5 million kilometer, which is about 1% of Earth-Sun distance. How many payloads in Aditya L1? A. 7 payloads, B. 5 payloads, C. 6 payloads, D. 4 payloads. The answer is A. 7 payloads. All the 7 payloads are developed indigenously by ISRO and in collaboration with Indian academic institutes. 5 of them were developed only by ISRO, 2 by ISRO plus Indian academic institutes. Out of the 7 payloads, 4 are remote sensing satellites and 3 are in situ observation satellites. VLEC, SUIT, SOLEX, Helios are all remote sensing satellites. Aspects, PAPA, Advanced Triaxial High Resolution Digital Magnetometers or in situ observation satellites. Let us look a little deep into payloads since for any mission payloads are very important. VLEC is the main payload, which is visible emission line chronograph used to study solar corona. SOT, Solar Ultraviolet Imaging Telescope, which will capture UV image of the solar photosphere and chromosphere. SOLEX and Helios are used for X-ray flares analysis. SOLEX expands to Solar Low Energy X-ray Spectrometer. Helios HEL1OS, which can be comfortably remembered as Helios, high energy L1 orbiting X-ray spectrometer. Aspects and papa are used for studying solar wind and energetic ions. Aspects expand to Aditya solar wind particle experiment. Papa expands to plasma analyzer package for Aditya. Advanced triaxial high resolution digital magnetometers are used for in situ magnetic field analysis. This table gives detailed information of 7 payloads. You can please pause and note down the information if you want to. Question number 6. Which one is remote sensing payload of Aditya L1? If you have listened to the previous slide, you would be able to answer this question. It is SOOT. Aspects Papa triaxial digital manometers are all in situ satellites. 7. Which one is in situ payload of Aditya L1? It is Papa. Solex, Soot, PELC are all remote sensing satellites of Aditya 1. Question number 8. Name Aditya is derived from which language? A. Prakrit, B. Hindi, C. Tamil, D. Sanskrit. The answer is D. Sanskrit. Question number 9. In Aditya L1, L1 denotes A. Lagrange point 1, B. Langerhans point 1, C. Laplace point 1, D. Lippershey point 1. The answer is A. Lagrange point 1. Question number 10. Orbit in which Aditya L1 to be placed. A. Helio orbit, B. Halo orbit, C. Polar orbit, D. Geostationary orbit. The answer is B. Halo orbit. We will explain what is halo orbit in upcoming slides. Let us move to next question. Objectives of Aditya L1 is to study A. Corona, B. Chromosphere, C. Solar winds or flares, D. All of them. The answer is D. All of them. Question 12. Which countries have attempted solar mission? A. Europe, B. USA, C. Japan, D. China, E. All the above. The answer is E. All the above. Name of these space agencies are Europe, ESA, Europe Space Agency, USA, we all know, NASA. NASA expands to National Aeronautics and Space Administration. Japan, JAXA, Japan Aerospace Exploration Agency. China, CNSA, China National Space Administration. One task for you all is, please comment below which countries have sent what mission to Sun. That is, please mention the mission's name to Sun. Example, USA have sent Parker probe to analyze Sun's atmosphere. Similarly, comment below what Europe has sent, China and Japan, the probes which these countries have sent to Sun already. Let's move on to the next question. Question number 3. In Aditya L1, L1 point is named after A. Joseph Louis Lagrange, B. Langerhans, C. Laplace, D. Lippershey. The answer is A. Joseph Louis Lagrange. Note: it has been named after Italian-French mathematician Joseph Louis Lagrange. Who was the first one to find these positions? Just look through Langerhans, Laplace, and Lippershey. What have they contributed? These peoples were mathematicians and well versed in physics. Just try to find out the observations by them and the foundings of them. Lippershey has invented telescope. Similarly, note down what Langerhans and Laplace has done. Question number 14. How many layers does the sun have? A. 5 layers, B. 6 layers, C. 7 layers, D. 8 layers. The answer is D. 8 layers. Let us look into the layers of the sun. In this image, the outer bright portion is corona. Next comes the chromosphere, after which comes the photosphere. Please take a note of the order of layers. The brightest spot and where the temperature is high, the color of it will be blue. Note the color of the core. More detailed information about Aditya L1. As we discussed, Aditya in Sanskrit means sun. L1 is Lagrange point where gravitational forces between two celestial bodies such as sun and earth or any two celestial bodies for that matter are in equilibrium. That means there is no force acting on the body pulling it towards it or pushing it away from it. Since net force acting on it is zero, the object will be relatively stable, which gives more fuel accuracy. So we have launched Aditya L1 from the Earth. It's expected to rotate in concentric fashion and move and rotate in L point in an elliptical orbit. Let's move to the next slide. What are Lagrange points? There are 5 Lagrange points L1 to L5. These can be used as parking spots as per NASA. This actually means that fuel consumption is very minimal to keep it in its position. These points have gravitational pull of the celestial body equals to the centripetal force that required to keep this third body in orbit. That is, the forces acting on third body cancel each other out, which means it's stable to rotate in its orbit. Objectives of Aditya L1 are to study upper atmospheric layers of the sun called chromosphere and corona. We should note that no probe has been sent to analyze deep into the sun. Only the atmospheric layers and surrounding of the sun are analyzed till now. So if any question is asked, the probe is analyzing interior of the core of the sun, it will be wrong. We are just analyzing its atmospheric layers, upper atmospheric layers, not the inner ones. To examine coronal mass ejection which takes place from the surface of the sun, that is plasma and magnetic fields from sun's corona. And we are also analyzing magnetic field from sun's corona, which actually drives the space feather in itself. There's also one typical point where in corona it is not bright but it is million-degree hot. But the surface of the sun is just 5500 degrees Celsius. We are also curious about what's happening with the temperature of the sun. Scientists will know the reasons behind the acceleration of the particles on the sun, which actually leads to solar wind. Recently, we would have listened to news saying that due to solar flares, the entire electromagnetic waves have been interrupted and we did not receive signal in our phones or any electronic devices. This was due to solar flares from the sun. We will actually understand the underlying reasons for why the solar flares occurs. What is halo orbit? Orbit about an unstable Lagrange point with minimum use of thrusters for station keeping is halo orbit according to NASA. That is, with minimum use of fuel, we were able to keep our satellites in the place. It appears in an ellipse floating over the planet, elliptical shape. Note, European Space Agency's Solar Heliospheric Observatory spacecraft SOHO is also stationed at Halo orbit around the L1 point of Sun Earth system. It's been operational since 1999 and have discovered more than 400 comets. It has also studied outer layers of the sun and examined solar winds. Why will the probe go around L1, not L2, L3, L4, or L5? It is because L gets continuous view of sun. Example, if sun is here and our earth is here, the L1 point is somewhere here, which is directly between earth and the sun, which gets continuous view of the sun. L2 is located behind the earth. Thus, view of sun is hindered. L3 is behind the sun. So we will not be able to receive communication from L3. L4 and L5 are good and stable, but it is much far away from the earth compared to L1, and cost expense is high, and at the same time receiving information is also difficult. For if we have to analyze the entire universe or celestial orbits outside the solar system, we can try stationing at L4 and L5. About 5 Lagrangian points, L2, L3, and L1 are unstable, L4 and L5 are stable. They are also called as Trojan points, where celestial bodies like asteroids are found. And $1 million question, why should we study sun from the space? Why not from Earth? According to ISRO, sun emits radiation light of almost all wavelengths according to various energetic particles and magnetic fields. But atmosphere of our Earth is the protective shield which protects us from harmful wavelengths radiation including particles so that we do not receive all the rays of the sun. This means we cannot get a complete picture from inside the earth. To get full view of the sun, we have to observe sun outside the planet's atmosphere, that is from the space. By observing sun from the space, it is expected to unveil mysterious facts and backgrounds and the functionality of sun in its whole sense. We might even land up getting shocking information about the half-lived star which is our sun. We will not just reach for the stars, we will reach for the sun, says Aditya L1. All the best. Thank you and stay tuned to our channel Focus Prep IAS. Please don't forget to comment below the solar missions sent by various countries. Thank you.